The Monitoring of Microclimate and Air Pollution in Thailand project. This is a project focused on monitoring and studying air pollutants and their chemical characteristics and meteorological data near ground level. As you know, Bangkok area is Asian megacity with rapid population growth. It has resulted in a significant degradation of air quality due to increased number of vehicles, traffic jam, and also changing urbanization profile, especially at the present the problem of fine particulate matter or PM2.5. So, the monitoring and study of vertical data of air pollutants and meteorological data is a key point for understanding atmospheric phenomenon and managing air quality in Bangkok. The monitoring station was constructed in 2014 for monitoring the air pollutant and also the related parameters for big database of air pollutants in Bangkok, Thailand. The project was funded by Hydroformatics Institute or HII in Thailand. So this is a project that we call the monitoring station KU Tower. KU Tower is a tower for atmospheric measurement with height of 117 meters. The tower is the tallest air pollutant monitoring tower in the Southeast Asia. This tower, operated by the Faculty of Environment, Atmospheric Science Research Group or ASRG. And you can see the picture from 2014 until the KU Tower finally construction and reused until now. So the ASRG group consists of lecturers, researchers, PhD students, master students, and also undergraduate students of the Faculty of Environment. Under head of the project, Assistant Professor Dr. Surat Bualer. At the present, so ASRG is working on air quality monitoring and chemical analysis of particles, warning system of air quality for the people around Kazisat University, and research related to air pollution. For example, in last year, 2020, and this year, we're working on the research in the topic of the source apportionment of PM2.5 and mechanism process of secondary particles in micrometeorological condition using chemical and particle etching technique. And another research that is very important problem for the Ratchaburi province in Thailand is the source apportionment of ozone and PM2.5. This research is focused on the PM2.5 sources, emission sources. So after we know which source of PM2.5, we can managing the emission source directly, and this is the significant solution for managing air pollution in the Thailand and also in the other countries. In the future, so we plan to measure real-time chemical analysis of the particles for source apportionment of the particles. So this is the KU Tower. You can see the KU Tower is a very tall tower near Faculty of Environment. So this tower monitoring the atmospheric at the 3 levels. 30, 75, and 110 meters, and monitor the microclimate at 5 levels: 10, 30, 50, 75, and 110 meters. And this is the parameter that we measure simultaneously and continuously. The meteorological data, that is a very important factor to know the phenomenon of the air quality. So we measure the temperature, wind speed, wind direction, relative humidity, pressure, precipitation, heat flux, and radiation. And the key point of the monitoring is the air pollutants, which is a particulate matter. This one is the monitor the PM for PM 2.5, and it can change some part for measure the PM 10. And we also measure the gases in the atmosphere: NOx, sulfur dioxide, ozone, carbon monoxide, methane, and also the total hydrocarbon. And this one is the ultrasound to measure the carbon dioxide flux. So we can know the carbon dioxide direction in this area. That is the very useful to know the green area, that to plan the advantage of the green area or the green city for the urban planning. And in the special case, so we have to go to some area in the air pollution case, such as the VOC fugitive emission in the industry area or heat episode in the northern of Thailand. So this is the air quality monitoring mobile. So in this truck, in the small truck, so we have the analyzer to use to measure such as the gases or some compound that we interesting in that area. Volatile organic compounds or VOC analyzer, that is a very important one. And sometimes we also use the humidified tandem differential mobility analyzer. In the short name is the HTDMA. This system to use for to investigate the hygroscopic growth factor. That is the one important parameter of the particle to know the characteristic of the particle, and it can grow up to a bigger and bigger if that area is the very dense of the vapor. So we can know how particle grow to which size of particle. This is the picture of our research team. So we have some event and important event to go out and to measure particle, gases, and meteorological data, to analyze the data and analyze the chemical composition, to find the suitable way to managing the air problem in that area. And we got exchange researcher from many countries. And this is some example area that the KU Air Quality Monitoring Mobile measure the pollution, not only in the Bangkok but also in Rayong province, in northern of Thailand in Chiang Rai province, and also in Ratchaburi province. In laboratory, this laboratory is on the seventh floor of Faculty of Environment building. So the aim of this laboratory is to research and analyze the chemical characteristic of the particle, and we also use the computer software for use for the air particle and also the gases modeling to predict the chemical component and also the air pollutants concentration in the predicted area. So this is the environment of the atmospheric laboratory at the 7th floor of the Faculty of Environment. And the next room is the office room for researcher and student from the undergraduate course, master course, and also PhD. So we have a small group, but we have a team to analyze the many characteristics of the particle and monitoring the air pollution data in the 24 hours. So sometimes we have to use some equipment in other room in the Faculty of Environment or to analyze some chemical composition in the outside of our faculty or outside of the Kasetsat University in the sometime. So this is the analyzer and also the particle monitoring equipment in laboratory. The black one is the OCEC analyzer. OC is the organic carbon, EC elemental carbon. This analyzer is to analyze the carbon components in particle. So after we collect the particle on the filter, so we put filter in this analyzer with the thermal optical method to analyze the organic carbon or OC and elemental carbon for EC. This one temperate element oscillating microbalance we call TEOM. This TEOM used to measure the particles smaller than 10 micron and particles smaller than 2.5 micron or PM10 and PM2.5. And after measure the particle concentration, the sampler send the data to the Kasetsat University to show the data for the student and staff and also the people to know on the website and KU application too. We also use the computer for the air modeling. And this one on the left hand side is ion chromatography to analyze the ion in particle such as nitrate, sulfate that is on the particle is the one parameter of the chemical component. That is the very important one because after we know the ion in particle or carbon in particle, so we can find the emission sources of that particle, and after that, so we can know the emission source and manage the particle from that emission source to reduce the particle concentration in the atmosphere. To use the atmospheric modeling by the computer software, so we have the many program, for example, AMOD to predict the particle and also the gases dispersion to area that is interesting. Also used for the analyze the wind speed. This picture, so we call wind rows to know the wind speed and wind direction. So the KU tower, that a tower for monitoring air pollutants and meteorological data. So after we use this for more than 7 years, so we have a big data of air pollutants concentration, consists of particles and gases, and meteorological data for design and adjust a weather forecast model for the Thailand. And after we use the many equipment, especially the HTDMA, so that is the equipment for study the hygroscopic growth factor of the particle. So it is the very important factor to increase the precipitation in the area. And the investigation of the function of green area by use the ultrasound for major carbon dioxide flux. And finally, to use the data for identify the emission source or source apportionment of pollutants in Bangkok, Thailand. And this is the research project of the atmospheric group in the Bangkok and other province, Samut Prakan, for monitoring air quality in Khung Bang Krachao and Rajpuri province to investigate the PM2.5 and identify PM2.5 emission sources, and also to study the ozone concentration from the Bangkok to Rajpuri province area. And moreover, so we also study in the Phetchaburi province to measure the energy balance and carbon dioxide flux. And in the northern of Thailand, we cooperate with the Chiang Mai University to research to find the solution for heat episode in the northern of the Thailand. This is the picture that we on the field to measure the atmospheric pollution and meteorological data in the area of the Phetchaburi province in Lam Papia project. And we also very welcome the visitor from the many country and many institute, university in Thailand and from the many country from outside Thailand. So if you have the chance, so please visiting the KU Tower so you can see the inside analyzer and also the how it work to operate in 24 hours. This one for the project at the northern of the Thailand for the result of the heat episode in the Nan province. So we study the particle concentration in the village area, outside and inside a home, and the many characteristics of the home or the office and building. So after we measuring the particle concentration outside or the outdoor environment and indoor environment, so we can know the problem is from the village or the house pattern, and also the problem of the air ventilation. That is the key point to manage the good air quality in indoor environment. This one to the major the atmospheric pollution in the green area in the city and also the major carbon dioxide flood. This one also the picture to study in the northern of the Thailand area. We use this one, the drone, to the major particulate matter in the height level. So sometimes we want to know the particle concentration more than 100 meters above the ground to know how the particle and also the atmospheric pollutants in this area movement in the vertical characteristic. So we have to use a drone to measure the particle in the high level to compare with the ground level. So this is KU mobile, so we can use some sampler to monitor the particle concentration in the top of this small tower around the 10 meters and use the drone to climb up to in the sky around 100 meters to measure the particle in the same time. This is another one, the research project to study the ozone concentration from the Bangkok area to Ratchaburi province. So this site is the Kasetsart University and the left hand side is the area of the Ratchaburi province. So as we know that the ozone is the one of the adverse effect air pollutants that is the high concentration in winter in the central area of the Thailand. So this research found that the ozone concentration can move from the Bangkok that is the very dense of the concentration of the NOx or nitrogen oxide and also the other pollutant that the formation of the ozone occur in the Bangkok, and the ozone concentration can move from the Bangkok to the other province such as the Samut Sakhon province, Samut Songkhram province, and also Ratchaburi province. So we use drone to measure the ozone and nitrogen oxide in the station around the 13 station from Bangkok to Ratchaburi province and study ozone movement from one area to another area. And that you can know the air quality also from the other websites, not only in the Bangkok and also the other country. So Kasetsart University is also published the real-time air quality on the website of university too. So you can find the real-time air quality PM2.5 concentration in 1 hour average and in the 24-hour average and PM 2.5 concentration in the real time in the website at aq.ku.ac.th. And now we also publish the ozone concentration on the website in 1 hour average because we found that in the winter and some season, in the sometimes ozone concentration is very high. So the people around Kasetsat University or Bangkok so can use this concentration, air quality concentration to the plan for your activities on the daily life. And after you can check the real-time air quality. So if you're interested in the atmospheric data or the prediction of the weather in the Bangkok, so you can find many information in Facebook page สิ่งแวดล้อมเกษตร that ASRG. So you can find many information about the atmospheric concentration, atmospheric the prediction or the weather, and on the website ny.ku.ac.th. And if you're interested on the sampler or equipment, so we have the laboratory at the 7th floor of Faculty of Environment, or you can contact the Dr. Tanyapat in the email tanyapat.t@ku.ac.th too. So thank you very much for watching this video clip.
ในลักษณะของที่โครงการเราวัดอยู่เซ็นเซอร์เราจะประกอบด้วยกัน2ที่แรกเนี่ยจะอยู่บน JU Tower พวกก๊าซต่างๆจะถูกเก็บที่นั่นในขณะเดียวกันตัวฝุ่นละอองก็จะมีหุ่นยนต์ปีนขึ้นไปแล้วก็ไปวางไว้ในจุดที่ระดับ30เมตร75เมตรแล้วก็110เมตรที่เสานั้นดังนั้นข้อมูลเหล่านี้จะถูกประมวลผลร่วมกันระหว่างก๊าซฝุ่นแล้วก็ส่งข้อมูลเข้ามาในห้องแลบแล้วใช้การวิเคราะห์ควบคู่เทคนิคควบคู่กันไปด้วยเพื่อหาว่าข้างในมันมีองค์ประกอบอะไรบ้างสำหรับเครื่องมือตัวแรกที่เราใช้ในห้องปฏิบัติการนี้ก็เป็นการตรวจวัดฝุ่นในลักษณะของความเข้มข้นออนไลน์นะครับเป็นเรียลไทม์ที่เราสามารถวัดได้เครื่องมือเราใช้มาตรฐานเดียวกับของกรมควบคุมมลพิษและมาตรฐานอื่นทั่วโลกก็คือเราใช้ทีโอมในการตรวจวัดฝุ่นขนาด2.5 แล้วก็ฝุ่น PM10 ค่าก็จะวัดออนไลน์ขึ้นมาตรงหน้าจอนะครับบรรทัดแรกเนี่ยจะเป็นความเข้มข้นเฉลี่ยในรายชั่วโมงนะครับส่วนบรรทัดต่อไปนี่เป็น8ชั่วโมง12ชั่วโมงและสุดท้ายที่เราไปเทียบกับมาตรฐานก็คือ24ชั่วโมงนะครับตอนนี้ตัวเลขอยู่ประมาณ54ก็เกินมาตรฐานมาเล็กน้อยนะครับเกินมาตรฐานมาเล็กน้อยวัตถุประสงค์หลักของเราใช้เพื่องานวิจัยนั้นข้อมูลนี้เราก็จะใช้เปรียบเทียบกับค่าการตรวจวัดของเราซึ่งเราไปเก็บตัวอย่างฝุ่นละอองในบรรยากาศมาอยู่ในรูปของฟิลเตอร์ในฟิลเตอร์เนี่ยเราก็จะมีลักษณะของฝุ่นที่มีแตกต่างกันออกไปเราก็จะเอาตัวกระดาษกรองเนี้ยมาวิเคราะห์องค์ประกอบข้างในว่าเขามีอะไรบ้างอันตรายไหมหรือมันมาจากอะไรเราสามารถที่จะหาได้ว่าใครเป็นคนปล่อยออกมาหรือแหล่งกำเนิดเข้ามาจากไหนตัวแรกที่เห็นตัวนี้เครื่องมือตัวนี้เราเรียกว่า OCEC Analyzer เราก็จะเอากระดาษกรองมาวิเคราะห์องค์ประกอบข้างในก็จะบอกได้ว่าฝุ่นเหล่านั้นมีออร์แกนิกคาร์บอนแล้วก็อิเลเมนทัลคาร์บอนสัดส่วนเท่าไหร่บ้างอีกตัวหนึ่งเราใช้ควบคู่กันไปกระดาษกรองเดียวกันที่เราเก็บมาก็จะถูกมาวิเคราะห์ว่าข้างในเนี่ยมันมีองค์ประกอบของธาตุไอออนิกอะไรบ้างทั้งแคททั้งแอนไอออนซึ่งเหล่านี้ก็จะถูกใช้ประมวลผลร่วมกันกับเรื่องของตัวฝุ่นความเข้มข้นข้อมูลสำหรับในการวิเคราะห์ตัวเสานี้เราดำเนินงานมาแล้วประมาณสัก 3-4 ปีเก็บข้อมูลต่อเนื่อง24ชั่วโมงในช่วงมกราที่ผ่านมาเรามีอะไรที่ค่อนข้างแตกต่างจากเดิมเช่นมีฝนตกในฤดูหนาวมีอากาศที่เย็นมีลมที่เข้ามาทางทิศตะวันออกที่ค่อนข้างแรงและพัดพาเอามลสารเข้ามาด้วยมันก็เลยทำให้ผลของการเปลี่ยนแปลงเหล่านี้ส่งผลไปยังตัวความเข้มข้นของมลสารรวมทั้งฝุ่นที่เรากำลังเจอตอน